SUMENEP, located at the eastern tip of Madura Island and surrounded by the ocean, this region holds significant marine potential. According to Belva in 2024, SUMENEP's capture fisheries potential reached 44,700 tons per year. This potential naturally attracts interest from other regions, leading to an influx of non-local fishermen entering SUMENEP's water to catch fish. And outrage fishing or illegal fishing beyond permitted boundaries occurs frequently, causing losses to the local community and even the country. One such case happened in Manyat, where non-local or non-SUMENEP fishermen entered and caught fish outside the allowed boundaries. This practice is commonly known as illegal fishing. Many cases have been reported, yet to this day, an efficient and effective preventive solution has not been found. Several measures have been implemented, such as VMS, FIRST and SARS-CoV-1, and routine patrol. However, with SUMENEP's waters covering 1,400 square kilometers, patrols are challenging and require substantial funding. On the other hand, satellite-based surveillance such as FIRST and SAR cannot be accessed in real time, while VMS is only limited to monitoring vessels above 30 GT, making this solution inefficient. Meanwhile, drones have been widely used as surveillance system, whether for fire detection, hazardous comporting monitoring, and so many others. With that, I'm Clarissa and my team, Milladitya. We are proud to present the surveillance drone system to build fisheries continuity in SUMENEP with Sentinel SAR-1, synchronization FIRST, and VMS. Our drone indicator is hull number and ship's flag, where the illegal fishing rarely happen. The obtained data then analyzed by match done into the database.
Here are our research problems. And the purpose of this research is knowing to design programs, mechanism, and effectivity with our drones due to illegal fishing. The methodology is first program development, drone assembly, and drone test. In the process, the images are altered in size to 800 by 800 to match the model and the CNN analyze predicts in the real-time detection box and the probability of the object. This project promotes the introduction of objects into categories such as things, people, or textile. The yellow model uses non-maximum suppression or NMS to eliminate excess barrier boxes, increasing efficiency of detections. With OpenCV, this process was carried out through a CV2 DNS and MS box to make out the box of demonstration and CV2 interval to show them in picture or video. The AI was trained using 1500 datasets, each labeled with a polygon system that follows the shape of those targeted objects. The dataset is divided into three parts: training sets, validation sets, and the test sets. And this is the program to train AI. The analysis of effectiveness program using three measures. One is equal loss. This measure how well the predicted box matches the ground truths considering distance and scale using CLOU or PLOU. 2. Class loss evaluates the accuracy of object classification within the predicted box, typically using BCE loss or focal loss to handle class imbalance. 3. DVL loss is used to anchor free model like yellow VH to improve bonding box accuracy through probability distributions. The training analysis saw progress with the final values of loss, bug loss at 1.3, class loss at 1.3, and DFL loss at 1.5, indicating a decreasing detection error. Meanwhile, in the validation phase, this error also decreased, but not significantly as in the training, with bug loss at 1.8, class loss at 2, and DVL loss at 2. The final stage of AI training involves analyzing error metrics. In the final results, so precision at 0.5, recall at 0.25, and MAP15 at 0.35, and MAP15 to 95 at 0.2. The increasing precision indicates reduction detection error.
The drone implementation took place at Southern Beach, SUMENEP on January 30 at 30 past 4 local time to assess the effects. In a controlled environment, the drone successfully flew autonomously, followed program paths, and avoided obstacles. The detection success rate reached 70% for moving ships in real time and 80% for stationary ships. Based on testing data, the throttle must be set at 80% to achieve the minimum thrust with a weight of 2.553 kg with 4 propellers. Each motor must be generate at least 638.25 grams of thrust at 80% throttle. Each motor produces 640 grams of thrust, ensuring sufficient lift capacity for the drone. Next, LoRa obtained projected values shown in the table, illustrating the relationship between distance and RSI value for LoRa communication. The best results were achieved at distance of 1 to 3 km, with RSI values ranging from minus 198 dBm to minus 208 dBm. The lower RSI value, the better the drone's ability to transmit signals to the base.
The results shown on the graph illustrate a comparison of the system response before and after optimization, with the horizontal axis representing the time and vertical axis representing the roll angle. Post-optimization, the curve indicates that the drone achieved stability more rapidly, specifically in 0.892 seconds compared to the previous 5.87 seconds. Additionally, the oscillation observed are significantly reduced.
The data shows that the drone detected sun shift in 20 minutes. However, it recorded coordinates magnified by 10 until 20 meters from the actual location. Additionally, vessels 7 and 8 lack whole numbers of flags, raising suspicions of illegal fishing. The coordinates obtained from the data test were compared with FIRST and SAR data. These are commonly used to detect illegal fishing. The results show zero data match, indicating the SAR and FIRST cannot be applied for certain areas of the sea, making them less effective implementation in certain areas, especially as SUMENEP. In conclusion, the drone with the YOLO version 8 model proved effective in detecting illegal fishing. The presence of training vessel through 50,000 dataset divided into 150 epochs, with the success rate was 70% for moving ship and 80% for static ship. The lead that needs to be turned on is 80% per rule, with only 740 breaths, while FIRST and SAR didn't get much data with the drone, where drones are more effective at detecting illegal fishing and